We're all on it pretty much every second of every day. But have you ever stopped to think about how the internet really works? What's actually happening behind the screen? It can feel like pure magic, but it's not. It's an incredible physical journey that your data takes every single time you click. In this explainer, we're going to pull back the curtain and show you exactly what's going on. Let's get right into it. So think about it. You click on a link, and poof, a web page just appears, almost instantly. But in that tiny fraction of a second, your request might have traveled thousands of miles, maybe even across oceans and continents. So what is going on in that blink of an eye? Okay, first things first, let's bust a huge myth. The internet isn't some magical, ethereal cloud floating up in the sky. Nope, it is a massive, very real physical system. We're talking about a global network of actual wires, cables, routers, and servers, all working together to shuttle data around the world as tiny pulses of light and electricity. At its very core, the best way to describe the internet is a network of networks. It's completely decentralized. That means there's no single point of control, no big red off switch for the whole thing. And that's exactly what makes it so incredibly resilient. Computers and networks can join or leave all the time without crashing the system, which is how it connects billions of us all across the globe. Now, to keep all that data from turning into total chaos with billions of devices trying to talk at once, the internet runs on a shared set of rules. You can think of them as the official traffic laws for the digital world, and the two most important concepts you need to know are packets and protocols. Here's a wild thought. Everything you do online, whether you're sending an email, posting a photo, or even watching this, doesn't travel in one giant piece. It gets chopped up into these tiny, manageable little chunks called packets. This whole process is called packet switching, and it's the secret sauce to the internet's amazing efficiency. It's how it can handle so much traffic at the same time. A really great way to picture this is to think about the Statue of Liberty, right? It was way too big to ship from France all in one go. So they broke it down, packed it into a bunch of different crates, and included instructions on how to put it all back together in New York. Packets work the exact same way. Each one is a little piece of the puzzle, and it carries instructions on where it's going and how it fits back into the big picture. So if packets are the crates, then protocols are the universal language that everyone agrees to write on the outside of the crates. They're basically a set of standardized rules that make sure any computer, anywhere, can understand the packets it receives, no matter what kind of device it is or what software it's running. It's the common ground for all communication. Now, there are a bunch of different protocols, and each one has a really specific job. The Internet Protocol, or IP, is like the postal service. It gives every device a unique address so the packets know where to go. TCP is kind of like getting delivery confirmation. It makes sure all the packets actually arrive and that they get put back together in the right order. HTTP is the protocol that basically builds the websites you see. And DNS? That's the internet's giant address book, turning a simple name like google.com into a numerical IP address that computers can actually find. Okay, so we've got the rules of the road. But what about the roads themselves? Well, that brings us to the internet backbone, the massive physical infrastructure that forms the global superhighway for all our data. The backbone is built on some seriously powerful hardware. We are talking about huge fiber optic cables that carry data as pulses of light, incredibly powerful routers that act like traffic cops directing packets, and these enormous data centers that house the servers where all the content on the internet, all the websites and videos and data actually lives. And the sheer scale of this is just staggering. There are literally millions of miles of these fiber optic cables laid across the ocean floors, physically connecting the continents. This is what puts the worldwide in World Wide Web. So who builds and runs all this stuff? It helps to know the key players. You've got the real heavy lifters, the network service providers, or NSPs. They're the ones building and maintaining that global backbone, the interstates. Then you have the company you probably pay every month, your internet service provider, or ISP. They connect to that backbone and then build the local roads that deliver the internet right to your doorstep. All right, so the data has zoomed across the globe on the backbone and it's reached your local area, thanks to your ISP. But how does it make that final crucial journey into your house? This is what's known in the biz as the last mile. There are really three main ways this last mile trip happens. You've got DSL, which uses the old school telephone lines. Then there's cable, which uses the same coaxial cables as your TV service, but you're often sharing that connection with your neighbors. And then you have fiber optic,
which is the current gold standard. It sends data as light through pure glass strands, giving you what is by far the fastest and most reliable connection.
Once that signal hits your house, two little boxes take over. The modem is the translator. It connects to your ISP and converts that incoming signal into a digital format your devices can understand. Then the router takes that one connection and creates your own private Wi-Fi network, acting like an air traffic controller to direct the internet to your laptop, your phone, your smart TV, everything. Okay, so we've covered packets, protocols, the backbone, and the last mile. We have all the pieces of the puzzle. Now for the fun part. Let's put it all together and trace the absolutely epic journey of a single click from start to finish. So here we go. You type in a web address. Instantly, your browser sends out a DNS query, basically asking, hey, what's the IP address for this site? Once it gets the address, it establishes a secure connection with that server. Then, your browser sends an HTTP request, saying, please send me the content for this page. The server says you got it, breaks the entire website into thousands of tiny packets, and fires them off. Those packets then travel across the global backbone, get routed through your ISP, and arrive at your modem. Finally, your browser catches all of them and reassembles them perfectly into the web page you see on your screen. And here is the truly mind-blowing part. That entire, incredibly complex journey across continents, through countless pieces of hardware, following a whole symphony of rules, all of that happens in the blink of an eye. We're talking a few milliseconds. It is a staggering feat of engineering. So, no, the internet isn't magic, but it's pretty magnificent, and it leaves us with a really fascinating question to think about. As our world gets more and more connected, as we plug in our cars, our homes, our coffee makers, and as we demand more and more data for things like AI and virtual reality, how is this invisible physical infrastructure going to have to evolve to keep up? What does the future of the internet's backbone even look like?